AI, or artificial intelligence, is all around us, whether we know we're interacting with it or not. AI refers to a collection of technologies that allow computers to sense, learn, reason, and act. But a far cry from the sci-fi promise of a humanoid robot that thinks like us, AI is currently only capable of specific individual tasks. AI powers the algorithms, the instructions encoded in computer programs, that rank search results on the web, tag your friends in photos online, let a smart assistant understand the words you say, and recommend which movie to watch next. AI can also help detect diseases, identify fraudulent credit card purchases, and monitor threatened ecosystems and wildlife. How does AI work? One approach is called machine learning. Equipped with algorithms and vast amounts of data called datasets, AI developers train computer programs to recognize patterns and tackle complex problems. In many cases, machine learning algorithms called neural networks extract information from examples in the training dataset by searching for patterns in multiple steps called layers. Once a program has been trained on a dataset, it can then encounter new scenarios and start making predictions. For example, if the training dataset is a collection of labeled images of cats, and the algorithm instructs the program to identify a cat, a successful image recognition program could then correctly classify a new image as either a cat or not a cat. If a language generator were successfully trained on all of the English text in a library's collection of books and articles, it could then complete an unfinished sentence while obeying the rules of English grammar. This process is not transparent. We have yet to design algorithms universally capable of explaining how they arrive at a particular answer. So we can't know exactly what makes our program so sure it sees a cat, or how exactly it knows that whom is correct, not who. It is just applying its training after being shown a huge number of examples. AI is impressive, but not perfect. Its flaws reflect the data we choose to train AI algorithms, as well as other choices made by the humans who develop these technologies and send them out into the world. Some of these flaws, like those in tools that determine credit scores, evaluate access to healthcare, and even attempt to predict crime, greatly impact human lives. That essential training dataset is a key point of weakness where misconceptions and biases can and do routinely sneak in. Here are some real-world examples where an incomplete or unbalanced training dataset causes unfair outcomes. A self-driving car might not be able to identify a person using a wheelchair in a crosswalk if wheelchair users were not included in the data when it was trained. Facial recognition programs trained on images that disproportionately represent faces with lighter skin exclude people with darker skin tones. We have the power to reduce this embedded bias by creating AI training datasets that mirror the complexity of the real world and lead to equitable and inclusive outcomes, and by building a diverse workforce of AI developers and decision makers. We must also consider social, economic, and ethical priorities when deciding which problems to tackle with AI in the first place. Each of us lives in a world filled with AI. The more we all know about where and how these technologies influence our lives, the better we can advocate for ourselves and others, and reach for a more equitable world.